Sorry about that interruption from my kiddos. But they always say, there's a famous saying that says, happy wife, happy life. But the reality is, man, does the world change when you have kids. Everything revolves around them. So, anyway, example 2. Let's take a peek back at example 1 and determine which ones are functions and which ones are not. Okay. Function. Mathematical rule written as an equation where each input has no more than one output. Okay. Back at the top. So, I mean, it's not mathematical, but I feel like this fails terribly because if you input cat into this sentence, what sound does a cat make? I mean, it could output a meow. It could output a purr. It could output a hiss. I mean, there are so many different outputs for that one input. So this just, it really fails. It's not mathematical, but in addition to that, more importantly, you put in one of these and you could have several different outputs. And so we're not sure about the output. Okay, so right off the bat, I'm going to say, which are not functions, sound. For sure. So many outputs for sound. How old is somebody? Now that, I mean, it doesn't feel very mathematical in nature, like written as an equation, but certainly for each individual at a very specific time, like right now, if you input some person's name, there is exactly one output. How old is Jake? Jake is 39. And then it's true that it moves on from time to time, but if you do this at a given time, there's only one output for that. So it does satisfy this part about each input has no more than one output. However, it's not really a mathematical rule, so this one is a little bit like, a little bit not, a little bit yes. So age. And that really depends on whether or not we can write it as a mathematical rule. This number 3, though, is clearly a function. A mathematical rule that can be written as an equation. So everything got doubled. What is blank doubled? Okay, well, we can write that as an equation. Y equals 2 times whatever you input. So if you input a number like 2, it will output a new number, so 2 times 2 makes 4. So the output would be 4. If you input 5, 2 times 5 makes 10. So this doubling was definitely a function. Here are 3 tables indicate which is a function and which is not a function. Okay, again, each input has no more than one output. Okay, so we're going to make the assumption that each one of these could be written as a mathematical rule. And now if we input 0, output 0. If we input 4, outputs 2. If we input 4, outputs, bad. Input 4 has 2 outputs. Okay, so this is out, not a function. All right, now let's do this again. If we input -2, it outputs 4. If we input 0, it outputs 1. If we input 2, it outputs 4. If we input 3, it outputs 9. Based on what we see here, this does qualify. So far, I mean, we're not sure. We know it doesn't fail yet. So assuming based on this, I would say yes. So maybe I'll write yes. So far so good. It has not broken the rule. Here, let's see. We input 0, it outputs 0. We input 2, it outputs 2. We input 4, it outputs 4. We input 5, it outputs 5. Yes, so far so good. And this one I can actually pretty quickly create a rule for this. So yes, so far. Here it looks like y equals x. Okay, number 3. But I also wanted to mention this example right here. A lot of people see the definition of having no more than one output, and they see these two 4s. But it is really important to note that those are outputs, and the rule doesn't say, it doesn't say that two different inputs can't have the same output, and that's what's happening here. It says that for each input has no more than one output. And here, so you just really have to keep track of this. In -2, output 4. And that's a different input than this. Input 2, output 4. So you just really have to keep saying it. If I input blank, it'll output yada yada. A circle with radius has the equation x squared plus y squared equals 9. Write down several ordered pairs that satisfy this equation. Okay, I'm actually going to tell you very specifically what I want you to compute here. So let's suppose for fun x is equal to 3. So we're inputting x equals 3. So when x equals 3, our equation looks like 3 squared plus y squared is equal to 9. And that means that 9 plus y squared is equal to 9, because 3 squared is equal to 9. And that means this has to be 0, because 9 plus, there's nothing you could put here except 0, so that 9 plus however much would equal 9. So that means that y has to be 0. So when we had this one input, when we input 3, it had this one output of 0. Now let's try a different value. Let's suppose for fun, we input 0. When x equals 0, 3 squared plus, oopsie, my bad, 0 squared plus y squared is equal to 9. What if I have white out? Always make mistakes. Just gotta fix them. Got it. When x equals 0, 0 squared plus y squared equals 9. And 0 squared is 0, so this is nothing plus y squared. And then we have to ask ourselves, what squared would give us 9? Well, 3 squared. 3 squared would equal 9, but there's another number that when we square it, we get 9 as well. -3, because -3 times -3 is also positive 9. So here we see that when we input x equals 0, the outputs are either 3 or -3. And that has broken the rule. Each input has no more than one output. So this input, it was okay with the rule, but this input broke the rule. And because it says for each input, this is not a function. Fail to be a function. Not a. So x squared plus y squared equals 9 is not a function. Okay, and I wanted to mention really quickly, okay, that a circle of radius 3, so what did we have? When x equals 3, y equals 0. And when when x equals 0, y was 3 or negative 3. I'm not particularly good at drawing circles. Okay, so rough sketch of a circle here. So this right here, x and y are definitely related, so we call it a relation, but they're not a function because when we input this value, we had two very distinct outputs, namely one here and one there. A parabola has the equation y equals x squared plus 1. Write down several ordered pairs. Oh, I feel like maybe we didn't do that up here. So just so that we rewrite this, okay, over here we had 3, 0. We also had 0, 3, and 0, negative 3. And actually we stopped right there because immediately when we had this input having 2, we were good to go. A parabola has the equation y equals x squared plus 1. Write down several ordered pairs that satisfy this equation. Then indicate if it's a function. Use your calculator and draw a picture. Okay, let's do it. For this problem, I'm actually going to go ahead and create a table of values. So, very similar to up here. All right, gonna randomly pick some numbers. I don't know, let's try 0. When x is 0, 0 squared is 0, 0 plus 1 is 1. When x is 1, we input 1 into this equation. 1 squared is 1, 1 plus 1 makes 2. How about when x is negative 1? Negative 1 squared, so negative 1 times negative 1 is positive 1. Positive 1 plus 1 makes 2. Okay, so I feel like every input that we do has exactly one output. I input 0 at output 1. I input 1 at output 2. I input negative 1 at output 2. I input 100, it'll output 100 squared plus 1, whatever that is. So I do think that this is a function. Without drawing a picture or anything, yes. Y equals x squared plus 1 is a function. Because for every input that we put in, there is exactly, or there is no more than one output. There's actually one output. Use your calculator to graph and draw a picture here. Okay, let's do that. Then we'll make some remarks. I've gone to y equals, and remember that x is right here on your calculator, and I've put in x squared plus 1. And I go to, so I'm going to hit zoom again and go down to standard. Okay, here comes our graph. And there is our graph using our graphing calculator. So just to remind you of how to use that graphing calculator, because we'll use it a lot. Okay, use your calculator to make a graph and draw it here. Got it? I can actually use these ordered pairs too. So Okay, these number lines go on and on. So I'm going to go ahead and label them because I feel inaccurate when I don't. Okay. Let's see. Okay, I just scaled by ones, but we certainly have 0, 1, and 1, 2, and negative 1, 2. And that's actually from the ones that we computed. But then the picture, whoa. Nope, still, okay, that's fine. I'm just going to draw. It had this arcing. Okay. Known as a parabola. So, write down several ordered pairs that satisfy the equation. Indicate if it's a function. Well, we had the ordered pair 0, 1, 1, 2, negative 1, 2. And then there are more ordered pairs. We just stopped there. But it definitely is a function because for each input, there were never more than one output. So we're good to go there. Let's make a few remarks and then we'll stop for the next example. Okay. My first remark is that just one situation where there are two outputs for one input makes it fail to be a function. So just one situation where there are two outputs for a given input makes a rule fail to be a function. Just takes one. Spoil the pot. It's like dumping in too much salt, then the whole batch of chili is out. Also, when we do figure this out, then we traditionally replace this y with an f of x. So we replace y with this notation, f parentheses x, and that happens when it's a function. And only when it's a function. And I'm going to say something about this in this video. So this is basically renaming it. It's saying, you know what, it's special. X squared plus y squared equals 9 is special because it's a circle and x and y are related. They're in a relationship together. But this relationship, y equals x squared plus 1, has a different type of relationship, and specifically we're going to call it a function, where it satisfies this thing where you input 1 and the output there is never more than one output. And that's very specific. It's a very specific type of relationship. And to me, this is very similar to a square being a special type of rectangle. So a rectangle is a closed image that has 4 90-degree angles. And it's two-dimensional. So hold on, and 4 sides, should I say that? Anyway, a rectangle is a closed 4-sided image that has 4 90-degree angles. And then a square square satisfies that definition, but in addition to that, it also has the property that every side is equal in length. So this is a relationship, but more specifically, it has this extra property, and so we rename it. It's renamed f of x because f stands for function. So But this notation just means it's an equation, it's a rule, and it satisfies this property. My next remark says f of x does not mean f times x. This is more of a warning. This notation is really confusing for a lot of students because a lot of times we use parentheses to indicate we're multiplying. But here, that's not what it's indicating. This double, like a repeat of notation here, is very specific to the context of the problem where we are renaming a known equation, namely one that's already been written or could be rewritten with a y. Okay, so this is a warning. Beware. This notation does not mean f times x. It means this is a function. That's its meaning. And then, okay, so here, f of x means the rule is a function with input x and output y, or f of x for that matter. Okay, and it also means that the output depends on the function rule f. So f is naming that function rule. And then my last remark before we do another example is we can use something other than f of x. F of x is vague, but we can change it to match the situation. We can use something like v of t, where v is the value and t is the time, or p of t, so where p is the price and t is the time, or a of t, where a is the area and t, you know, there's just so many different, but it doesn't have to be f of x. That's just, it's just open to interpretation. Whereas this is more specific to what we're working on. In the next example, we will look at a function, a specific function.